Hello, everyone. Welcome to our very interesting session, the last for this quarter, Gr10 Physical Sciences. My name is Themba Ncube. I'm pleased to be with you. Thanks for joining us. Today, our focus in Physical Sciences, Gr10, will be on the consolidation of all the concepts that we did or the knowledge areas that we did in the first quarter. There were two sections that we looked at this term, which was matter and materials, which is predominantly, that's the second paper, which is the chemistry, which is paper 2. And also in the remainder of the term, we also looked at matter and materials. We looked at sound, waves, and light, which is the physics, the paper 1. Now, in this session, our primary focus or objectives would be to try and consolidate, as I've mentioned, but also what will be critical is to remind ourselves of the concepts that we discussed, the key problem areas, maybe to guide each other in terms of preparedness. Now that we're at the time for the examinations, it will be very important to remind each other as well, and also to address the techniques in terms of responding to questions, and also look at the layout of the question paper, which is the standardized paper, which we shall be sitting from at the end of this term. Right. The two sections that we have looked at in this quarter are matter and materials. Matter and materials. So the matter and materials, as I've indicated, falls under the second paper, which is our chemistry. Right. Now, matter and materials, that's paper 2. And then the other part that we did in the remainder of this quarter was on waves, sound, and light. Waves, sound, and light. This one particularly falls under the physics. It's the physics, wave, sound, and light. Physics falls in the first paper, right? So that's our paper 1. So what will be key in today's session, as I've indicated, we want to address the techniques of responding to questions, as well as also remind ourselves of the key ideas or the key concepts, the most common misconceptions also in terms of responding to questions in a typical exam. Hopefully this shall be very beneficial, and also we shall be adequately prepared come the exams, now that it is that time of the quarter or the year where we sit and be assessed. Right, just to get us started, let's look at the layout of the paper. The layout of the paper, it has got two sections, which is the multiple choice and also the structured questions, which is the section B. Right, now with the multiple choice, as we shall establish, looking at the very first example problem, write down only the letter corresponding to the correct answer. It's very critical to also follow instructions, because instructions are a very integral part of an exam. Right, just to give us an idea of how we respond to multiple choice, I shall use this as an example, then subsequently I'll give you time to respond to a particular multiple choice to apply the very same technique or better in terms of trying those problems that I will give to you, so that at the end of the day we get some common understanding as to what's the best possible technique in terms of responding to multiple choice problems. Right, the first one says, when an atom, remember atom is the key word. Now we talk of an atom, it means this is the smallest particle of matter or an element with the same number of protons and electrons. So in other words, we must know that the atom is neutral. The atom is neutral. Also, the neutrality of the atom becomes very important in the sense that it has same number of protons and electrons. So number of protons, which is the positive charges, is equals to number of electrons, which is the negative charges. So the net charge of an atom is equals to 0. It is neither positive nor negative. So the understanding of the subatomic particles, so the P plus there, let's say it represents the proton, right? And then the E minus, it represents the electron. Remember, the electrons, they occupy the energy levels, and the protons, they are found in the nucleus of the atom. Right, so when an atom X of an element in group 1, it takes us back to the periodic table. If I may draw your attention to the periodic table, Okay, here is our periodic table, right? Now, element X is in group 1. It means it could be any of these elements in the first group. So what's common about these elements? They've got the same number of electrons at the highest energy level. It means those that I've highlighted, they've got only one electron at the highest energy level, okay, which we call the valence, right? So the valence of these elements is equal to 1. So X could be any of these elements, right? Let's go back to our question and check. So it means here, this element X in group 1, it ionizes. Remember, ionization has to do with removing or adding electrons. So ionization has to do with removing, okay, or adding electrons. It has absolutely nothing to do with the protons. Remember, if we remove electrons, it becomes a cation. So cation is a positively charged ion. After losing an electron, it can be one or many. Then on the other end, if we add electrons, we get an N ion. Very key, right? The N ion is negatively charged. We can only be negatively charged if we remove electrons. So if we remove electrons, it becomes positive. If we add electrons, it becomes negative, which is an N ion. So this is what is happening. There are 4 options, A, B, C, and D, right? So for us, we need to be very careful in terms of analyzing our answers. 2 of the possible solutions, we call them destructors. We call them destructors. So destructors, as the name suggests, it's just to disorganize you. So it's very important that you identify the destructors. So it says here, mass number of X increases. Mass number, it has to do with nucleons, right? Nucleons are in the nucleus. It means it has nothing to do with the electrons, right? And then atomic number of X decreases. Atomic number, again, it has to do with protons. Okay, it doesn't have to do with electrons. So A and B are our destructors. It will be easier for us to decide between C and D. Let's check each one of those. C says charge of the nucleus increases. The charge of the nucleus is always due to the protons, and the protons do not change. It means solution C is also not true. Now it leaves us with D. Number of occupied energy level decreases, which is very true. Now, if you go to our periodic table once again, you'd realize that all these elements that are in group 1, right, that's your hydrogen, lithium, and until cesium, those that we can see for now, they've got only one electron at the highest energy level. So if we can draw a dot cross diagram, there'll be one. Then the other orbitals or energy levels underneath have got more energy. So have got completely filled orbitals. It means then if we remove this electron at the highest energy level, then we would have this energy level being non-existent in a true sense. Then if we go to our questions, to our solution, it leaves us with the option D, which is primarily how we approach the multiple choice. Now, having discussed that, I'll briefly give you a couple of seconds to do the next question, work through it, use the very same approach, identify the destructors, and then maybe go on to decide as to which one is the most appropriate answer. Right. Okay. There is the question. Write down the letter corresponding. That's the instruction for all the multiple choice question. The outer electron structure of a magnesium ion is the same as which one? Just try that a minute or a couple of seconds to try that, and then we shall do the feedback together. Okay, guys, having attempted that, let's first of all identify the distractors in our in this particular question. If you look at it, why atoms of elements ionize? They ionize because they want to be stable, right? This is going, stability has to do with the chemical bonding, right? In this case, which can either be ionic, covalent, or metallic, right? Ionic, covalent, or metallic, but these are the most common, the two most common types of bonding. So stability has to do with which elements in the periodic table, elements in group 8. Let's look at the periodic table very quickly. When we talk of group 8 elements, we're talking about these elements in particular. These are very stable. So all these other elements, they want to achieve stability, which is similar to group 8 or group 18, depending whether you're using the main groups or the entire periodic table. So all these elements, they want to be like the group 8 elements. Right. Having said that, let's identify anything which is not a noble gas. Calcium is not a noble gas. Sodium is not a noble gas. Now we are left with two noble gases. We want to check. Magnesium is in group 2. What does it mean? If we're going to use the Lewis notation, at the highest energy level, it has got 2 electrons. For it to be stable, it needs 6, or it may lose 2. It will be easier to lose the 2 electrons. So if it loses 2 electrons, it simply means that it will form a magnesium 2+ ion. Okay? And then it will lose 2 electrons if it ionizes. Right. Now, once that happens, we go to a periodic table just to check as to the atomic number of magnesium. There is our magnesium. Magnesium is 12 electrons. Right. Now, if it loses 2, it will have 10. And now the 10 is exactly the neon that we're talking about. So if magnesium loses 2 electrons, it will have an electron structure similar to this element, which is neon. So if we go to our solutions, you'll check neon is the most appropriate one because argon has a greater number of electrons in its outermost in its entirety compared to neon. So the 10. So it means the magnesium ion has got 10 electrons. If that's what it means. If it's 10 electrons, then it's left with still the number of protons doesn't change. So it means it will have an electron structure similar to that of neon. Right. The next question, very quickly. If we can go to the next question, multiple choice. Surely now we've mastered the skill. Okay, it says, which element increases its electrical conductivity as its temperature increases? Now, this is very much straightforward, if I may indicate. Remember, electrical conductivity that changes with temperature has to do with a particular class or collection of elements in the periodic table, which we call the metalloids. Right, metalloids, the alternative name for metalloids are, we call them semi-metals. So when we looked at physical properties of metals, semi-metals, and non-metals, we agreed that these semi-metals, they have got both metallic and non-metallic properties. So if we can go to our periodic table once again and identify the element which is a semi-metal, it's your silicon. Remember the step, it goes on just like that. So in any one of these on the other side, on the right-hand side, including boron, silicon, it goes on and on. These are the ones that we classify as semi-metals. And anything to the left, it means going that way, it's metals. Then these are semi-metals. Then going all the way to noble gases, then we've got non-metals. Right. So between them, this is the transition block. Also classification is very, very important. So that's the D block or the transition metals. Now, if we were to go back to our solution, we'll check as to which one falls under the semi-metals. Sulfur is definitely not one of them. Okay. Cesium is not one of them. Cobalt's not one of them. We're talking about silicon, as you have indicated. Right. Now, this is the very key technique in terms of multiple choice. Now, say for argument's sake, there are 10 multiple choice questions. You need to give yourself at least 20 minutes because 10 in other words, implies that if each question is 2 marks, then you have got a total of 20 marks. You cannot reasonably respond to 20 marks in 5 minutes. So one other area which is always a downfall is to allocate adequate time in terms of responding to multiple choice questions. Right, with the multiple choice done for now, we shall take a short break, and then we shall come back after a short breather. Join us after the break, guys. Welcome back, guys. After the short break, let's quickly look at the structured questions. Now that we have an idea as to how exactly we respond to multiple choice problems, let's look at structured questions, which we sometimes refer to as long questions. This is the section B of any standardized paper. You need to familiarize yourself with that as well. Right, it says here, grade 10 learners were given substances, okay, in the table below. So there is a whole lot of them there that's given: brass, sand, oxygen, sugar, carbon dioxide, copper, pure air, salt solutions, table salt, salt solution, table salt, take note of that, magnesium oxide. Right, from the table, identify. Now we need to identify each one of the following from 2.1 until 2.5. I'll give you 2 minutes to try that, and then we shall do the feedback. Starting from now, 2 minutes. Welcome back, guys. Hopefully you've made your attempt on the question that has to do with identifying. The other key aspect of, in terms of maybe the approach, is also very key that you underline the keywords. The keyword in this case, in the context of this question, was identify. So to identify, you need to understand what an element is, and then know a couple of examples of what an element, a compound, homogeneous mixtures, heterogeneous mixture. So it is pretty much more about classification, which is very important. Right. An element, remember, it consists of atoms of the same kind. In this case, any element, you'll find it in the periodic table, right? So any substance which occurs in the periodic table is indeed an element made up of the atoms of the same kind, right? If you check very closely, copper is one such example, right? Copper is an element, right? Because it's a transition metal in the periodic table. It means it's made up of atoms of the same kind. You think of it, oxygen gas. Oxygen is also an element. However, oxygen does exist as a molecule, but this molecule consists of atoms of the same kind that are chemically joined together. It's not necessarily a compound. It is indeed an element because these are atoms of the same kind, right? Then there may be more than one, but in this case, these are the most obvious ones that come to mind in terms of elements. Right, now let's look at a homogeneous mixture. Homo means uniform with what respect in terms of maybe state of matter. So in a mixture, we've got a couple of substances, but these substances are not chemically joined together. Not joined together chemically. Joined in terms of bonded, not chemically joined or bonded. So it could be a couple of substances. However, these substances must practically be in the same state. We must be in a position to distinguish between the individual components that make up the mixture. Right. In this case, take for example a salt solution. Salt solution, you may think of it as also a homogeneous mixture. Pure air. Air consists of, for example, oxygen, nitrogen, carbon dioxide, sulfur dioxide, argon, you name them. All these substances are different, but they're not chemically joined together. So we would want to think of them as a typical example of a homogeneous mixture. Right. And also, let's look at a diatomic substance. Atomic substance. Di means two. We have already referred to oxygen, meaning that it has got two atoms of the same kind that are chemically joined together. Hence, oxygen is a typical example of a diatomic substance. Nitrogen is a diatomic substance. The other diatomic substance that you may think of as an example is hydrogen gas. Right. So hydrogen gas is also diatomic, meaning these are atoms of the same kind joined together or bonded together. Right. Let's look at a compound which is solid at 25 degrees. Right. Remember, when we talk about a compound, these are atoms of different kind, but these atoms are chemically joined together. So compound, they are joined together. Right. Joined together. That's very key. Joined together, but these are atoms of different kinds. So this temperature of 25 degrees is very important. We shall deal with it quite a lot of times in the sense that it has a lot to do with what we refer to as the room temperature. So 25 degrees is your average room temperature in sub-Saharan Africa. So you need to familiarize yourself with that. Every time you see room temperature, we are saying plus minus 25 degrees. So we want a compound. In this case, if you look at it, magnesium oxide is also a compound. At 25 degrees, it's also a solid, right? And also table salt, which is sometimes we refer to as sodium chloride. So table salt is what we call the common name. Then the chemical name, the scientific name is sodium chloride. So these two elements are chemically joined together. In magnesium oxide, MgO. These are two different elements which are chemically joined together. Right. And then a heterogeneous mixture. Hetero means non-uniform in a sense. Now, if you think of brass is an alloy of two different metals. An alloy is a mixture of metals, let's say, for example, zinc and copper, because of their physical properties, you can also think of it as a mixture, right? And also, sand has got a lot of components. You see, sometimes you observe some shiny particles. We may think of these as a heterogeneous mixture, right? Sugar is also a compound in the sense that it consists of carbon, hydrogen, and oxygen. These are the elements in different proportions that chemically bonded to give us sugar, which is also a compound. Right. So as far as identification is concerned, this was the key word in this context of this problem. Right. So it's always very important that you underline the keywords, read the question. Once you have responded to the question, go back to your answer and ask yourself if I indeed answered the question, and then we can move on. On that note, let's go further and look at a different context altogether. Right. This problem which we're going to attempt now, has a lot to do with the practical experiment that we did for this quarter, which had to do with the heating and cooling curve of water, which was the formal assessment. Now, it's very important that the scientific process which is involved in the experiment is also taken into account, because quite a lot the examiner would want to test your understanding of the observing, drawing conclusions, interpreting, In this case, you are given a table of results, which is the data, and then it was sketched through the data of temperature versus time. So typically, this is a graph of temperature versus time. It reads, Temba heated a substance X. We don't know what this substance X is. It could be any substance at a constant rate using a burner. So there's a piece of apparatus. He then drew a graph of temperature change versus time. So our title of the graph is temperature change versus time. So that's the heading. So if you are to draw any graph, it must have the heading. So in this case, temperature will be on the vertical axis, and then time always on the independent or horizontal axis. Right. Now, it's very important to understand that as far as this graph is concerned, time moves in that direction, okay, and then temperature increases in that direction, right? So point A, if I may correct that, that's our point A there. Then that's our point B, point C, D, E, and F. So this shows how temperature changes over a period of time as the substance is heated, right? Now, let's look at the questions in this. I'll go back to the sketch. We want to understand at which point. A point is, let's say, your A, your B, your C, your D, your E, or your F, or between which time intervals. Time intervals, it can be from 0 to 5 minutes, from 5 to 20 minutes. It's very important. So time interval, that's our change in time, okay? Then the point is at a particular point in time on the time axis. Okay, these are the questions. It says, does the substance X have no definite shape and molecules are moving freely? No definite shape, you underline that, okay? But then because we need to refer back to the graph, which will be very important, so that we can ask ourselves whether indeed have we answered the question. I'll draw your attention back to the graph, because these are typically basic recall questions. Now, I would like you to try these questions. At which point or between which time interval does substance X have no definite shape, and the molecules are freely moving? Now, it's very important that we draw our attention back to the graph. So it can either between time interval or between maybe points A and B, as we have shown. So that's our A, B, C, D, E, F. Okay, just 10 seconds for that. Okay. Okay, guys, what is important, I think, as you may have realized as you're trying to attempt this question, it has to do with basic recall. We've got the 3 states of matter, which is solid, okay, liquid, and then finally a gas, right? Assume this substance was being heated, it changed from that part to that in that order. Now, we need to understand the properties of a liquid, solid, and a gas. Definite shape, if there is not, the only phase of matter that has got a definite shape is the solid. So, in other words, the question is requiring of us to identify the time in which substance X was either a liquid or a gas. Now, check. Between A A and B, what is happening? The energy of the particles of that substance X is increasing. But between B and C, there is phase change. There is what we call phase change, which is the melting. So that's the physical property. So between C and D, the substance is a liquid. C and D is a liquid. I'll use the letters. The letters. And then between D and E is the final phase change from liquid to gas. That's why the energy of the particles of substance X remains constant. Right. Having said that, it's important that once it changes here between the E and F, so that's our F there, okay, the final point, it means the substance is a gas. So between these time intervals, then we have got the substance being a gas and a liquid, which actually addresses the fact that the substance has no definite shape and the particles are freely moving. Remember, in a solid, particles only vibrate within fixed position. So the movement is kind of restricted. However, there's greater amount of movement. And when we talk movement, we're talking about kinetic energy, the EK. Right, and then so in terms of a gas and a liquid, particles are moving freely. So moving freely suggests something about the kinetic energy of the particles. Right. I think that's the key idea. You need to understand the physical properties as well as what exactly characterizes each one of those three states of matter. For now, we shall go for a quick recess. Let's drink water and refresh. I think we're on a roll, and then we shall come back and do the remainder of the problems and continue to assist each other. Welcome back, guys. We are just looking at the question that has to do with the heating curve of a substance X. Substance X could be any substance. Remember the heating curve of water, which is directly related to what we're discussing at the moment. Now, we want to also use the graph. I prefer using the A, B, C's, and D's until A to F. Does the substance have a fixed shape? Fixed shape, remember, it's a solid, right? Is a solid, and then does X have no change in kinetic energy? This is a very key aspect of this concept, because when there is no change in kinetic energies, what is actually happening? It's a physical process which is to be taking place, a physical process. The physical process that we're referring to is either melting, all right, and boiling. Okay. Right, melting and boiling. This is the change from solid to liquid, then from liquid to gas. Right. So whenever there is a phase change, we know that indeed the kinetic energy of the particles remains constant. So remember, if we can go to our graph, between B and C there is phase change. Between D and E there is also phase change. So you can talk about the interval 18 to 26, okay, or we can talk about 6 to 12. That's where the phase change takes place. Very key. Right. Now, as far as the substance melting point, we're talking about the temperature, the specific what? Temperature. Very important. It's no longer the process. Now, it is the temperature at which that physical process is taking place. Now, when it says, is the substance X changed to a gas? In this case, the substance is already a gas. In other words, we shall look at the last part between the temperature of 140 and 180. At this time, the kinetic energy of the particles is increasing. Remember, temperature has a lot to do with the kinetic energy of the particles. The higher the kinetic energy, the higher the temperature. Okay, right. So we're talking about EF in that respect. Right. That's as far as the question is concerned on the heating and the cooling curve. Right. It's very important that you remember the key concepts as far as kinetic energy, phase change, and what exactly happens during a phase change. So in a typical phase change, temperature remains constant. After all has been said and done, that's what we need to take home, right? And temperature has a lot to do with the kinetic energy, which has to do with the movement of the particles, right? Now, let's look at a different aspect. It says here, chlorine is a non-metallic element with an atomic number. It's bold, atomic number. It's a key concept of 17, right? Then it can exist as isotopes, right? Isotopes is another concept which is a terminology which we interacted with, right? I'll give you a minute to do question 4.1.1 and 4.1.2. Right, which says define the following terms. A minute will be enough for that because this is recall. Recall to define, list, state is based on recall, which is to do with remembering. So particularly as far as remembering or recall type of questions, it's either you get the full marks or you get nothing. So I think this is the lowest order in terms of maybe complexity of questions. So as far as recalling, it's very important to pick up all those marks from the beginning. Right, a minute for that. Okay, guys, welcome back. Let's check if maybe we still recall the definitions. Defining, stating, listing, these are the easiest or what you call the lower order problems. So we expect learners to pick up quite a lot of marks on that, right? Because when we talk of an atomic number, it's very important. Atomic number gives us again the position of the element in the periodic table. But atomic number has to do with the number of protons. Hence, we call it the proton number, right? The proton number, right? The proton number. So in other words, when you look at chlorine, the symbol is Cl. Then let's say we've got 17 there. Then let's say maybe 35, okay? Right. So the 17 is the proton number. Okay, which has to do with the number of protons, or which is exactly what the atomic number is all about. So the symbol for proton number, we said it's A, and then the other one is mass number, right? Mass number, okay? Mass number is the nucleon number, the number of nucleons. Nothing suggests anything about the electrons. So the proton number and the mass number has to do with the nucleons, which are found in the nucleus of the atom. So the 35 has to do with the number of protons and neutrons, right? So when you talk of isotopes, right, you're talking about elements of the same, atoms of the same element that have got the same atomic number. It means the number of protons is the same, same atomic number, right? Same atomic number, but what will be different will be the mass number, right? So if the same atomic number, it means the number of protons is the same. The number which will be different is the number of neutrons, which are the neutral subatomic particles, different atomic mass. So we shall talk about different mass. So that's what is key about isotopes. So a chlorine has got isotopes. It means there is another chlorine which could have a different mass than 35. Okay, let's quickly look at why this happens and maybe talk about that in particular. The next question is of particular interest about chlorine. Remember atomic number of 17, right, which is the same in both isotopes, right, which exist as isotopes. We've quickly described what an isotope is in our not so long ago. So natural chlorine consists chlorine 35 and chlorine 37. So the 35 and the 37 are the masses. Now, in this case, we understand that the masses are different. Right. It says write down the SP notation for the chlorine 37. Remember, both the chlorine 37, okay, is an atomic number of 17, as well as the chlorine 35. has an atomic number of 17. So if we talk about the SP notation, we're talking about the electron configuration of an element. Right. Now, if you check, chlorine is 17. We know that it's divided into the S and the P orbitals. So in this case, we shall have 1s2 and then 2s2. Remember, the s orbital can only be occupied by a maximum of 2 electrons. The 1s is followed by the 2s. There is no 1p, which is often a mistake. Right. Then the 2p6. Already we've got 10 electrons. Now we want to reach 17. Right. Whether it's chlorine 37 or chlorine 35. And then we've got the 3s2. Right. 2, 4, 6, 12. And then the 3p5. Right. So the highest energy level of chlorine has got 7 electrons. Now, if I can draw your attention quickly to the periodic table, which is also our tool that we shall be using quite often, there is our chlorine. Chlorine is 35.5. Okay, that's the relative atomic mass. Then the 17 is the atomic number. Any isotope of chlorine, element chlorine, has got 17 protons. Right, which is very key to understand. Now, what is the number of valence electrons? Remember, valence electrons has to do with the group in which an element occurs in a periodic table. So if you check quickly in your periodic table, you'd realize that group 17 is same as group 7, right, which is written in Roman figura. So in terms of the main groups, group 17 is group 7. So chlorine, it means at the highest energy level, it has 7 valence electrons. So that 7 for the group has to do with the valence electrons, right? Okay. Having said that, it's very important to also know that the period has to do with the energy level. So group is valence, okay? All right. And then period has to do with the number of energy levels. So that's number of energy levels. Okay, so elements in period 1 have got 1 energy level, 2, and so forth. Right. Okay, let's look at a different problem altogether, which has to do with the bonding. Right. Now, bonding is a very key aspect of chemistry. Now, we use the Lewis diagrams to understand how elements are bond. Remember, the Lewis diagrams show electrons at the highest energy level, or the valence electron, but for a particular reason that these valence electrons are the ones that are involved in bonding. So if we take, for example, chlorine, which is diatomic, right? Chlorine is diatomic, meaning that it consists of 2 atoms of the same kind, chemically bonded. So the chemical formula is Cl2. Hence, you'll find it in that way. Right. So if you look at chlorine, it has got, let's say we've got 2 chlorine atoms there, right? And then these 2 chlorine atoms, each one of them has got 7 electrons. So at the highest energy level, it doesn't mean there's only 7. These are the only ones that are involved in bonding. Right. Let's say we shall use the dot cross diagram. Okay. The Lewis notation. Right. Now, to achieve a stable electron structure, these chlorine atoms, they want to have an electron structure similar to which element in the periodic table? If you can check the periodic table, the next element in group 8 is argon. Now, argon has got 18 electrons. Now, at the highest energy level, it has got 8 because it is in group 8, which is the valence. Right. Now, having said that, it means here there shall be the sharing of electrons. Once they share with each other, then they achieve a noble gas structure in terms of electron configuration. Then this is how we present using a Lewis diagram. So the type of bonding in this case, it has to do with the sharing, right? Remember, when we started our consolidation, we said sharing has to do with what? Covalent. Co means share. Then valent, it means electrons at the highest energy level. Very key. Right. Now, let's look at the other aspect which we discussed in this term, which has to do with wave, sound, and light. Right. A lot of questions come on interpretation. In this case, you are given a diagram which represents a water wave moving from left to right. Right. So that's the direction of motion there. Right. Okay. Then this is our axis where there is zero disturbance, which we called the rest position. which we call the rest position, right? So we've got different components there, your crest and your troughs, you know, your wavelengths, and then there are measurements that are given. It's very important to analyze the diagram very carefully. Then in terms of the diagram above, which represents a water wave moving from left to right, the time, it suggests something about T, which is the period, right? Taken for two consecutive crests, if you can check, for example, B and that point are consecutive crests, right? And also this point is consecutive to that. This makes a one pulse or one complete wavelength or pulse length, right? Wavelength, if you can put it that way, because now it's a series, we would refer to it as a wave. So in this case, the disturbance is up and down, okay? The direction of motion is in that way. So they are perpendicular to each other. Hence, we call a water wave, in terms of classification, we shall refer to it as a transverse wave. There are two types of waves. There is transverse and longitudinal wave. Okay, so the transverse wave in this case is in terms of classification, that's what it is, right? Okay, moving right along, I want us to check something as far as this question is concerned. It talks about amplitude, okay? Write down the amplitude of this wave. Amplitude is from rest position, right? That's our rest position to crest, or from rest position to trough. Now, any movement which is up and down in this case, in this axis, is 3 meters. So in other words, what the 3 meters is double the amplitude. In other words, so our amplitude will be half of that. That relationship is very important. So the amplitude is equals to 3 meters divided by 2. You need a calculator for that. In other words, the 3 meters is double the amplitude, in which case it works out to 1,5 meters, which is a straightforward question, which has to do with also a recall. Right. Now, the questions go on and on. In this case, we are still given that that's our period because it's 2 consecutive crests. But now, 2 consecutive crests, we know that these 2 crests, we say they are in phase, right? They are in phase. We can also think about many points that are in phase. Point A and point E are also in phase. They make a wavelength. In other words, point D and point F are also in phase. They make one wavelength. Okay, so points in phase, it means at this point, point D is moving upwards, and then again point F is moving upwards. Hence, we say they are in phase. But if you compare point B, let's say, and D, we say they are out of phase in the sense that the particles in the medium are moving in different directions at that point. So wavelength is to do with the distance. Wavelength is to do with the distance between 2 points that are in phase, and also must be consecutive. Consecutive meaning one must come after the other. Very, very, very key. Right. Okay. Now, there are many concepts as far as this transverse wave is concerned, right? To determine the wavelength, which is often a problem area for many learners. Now, we have, in this case, we are guided by the 6 meters, which shows in the direction of motion. So between B and this point, between these 6 meters, it means we've got 1.5 wavelength. Is it fine? It's 1.5 wavelength, which is in this case, this is our wavelength, and then this is half the wavelength. In other words, because these 2 points are in phase and consecutive, and then from here to that point, we've got half the wavelength. It's very important that to understand that this 6 meters is divided into 3 to get half the wavelength. So the 2 half wavelengths will make a single wavelength. In other words, if we say on our calculator, 6 divided by 3, we get 2 meters. What it simply means is that this half wavelength is 2 meters, and then this also from there to there is another 2 meters, another 2 meters, and then another 2 meters. So it means our wavelength in this case is 2 plus 2, which is 4 meters, right? Which is often one of the problem areas. But due to time constraints, there is a lot that we've touched. There's quite a lot, again, that still remains in terms of revising and reminding ourselves of what is key. We most certainly hope from my side that the interaction that we just had shall benefit you in terms of adequately preparing you for the exam. From myself, Themba Ncube, is cheers and goodbye for now, and all the best with your exam, guys. See you next time, next term, same place. Bye-bye.